Welcome back. In this lesson, we're going to be looking at variables and constants. We're going to look at the basic data types and understand the use of input and output. We're also going to be looking at the concept of sequence, selection, and iteration. Now, this part of the syllabus is called programming. However, there's a lot of crossover with the pseudocode that we had a look at in Unit 7. So if you're still not familiar with how pseudocode works, this lesson is a must to watch. However, if you do understand how pseudocode works, then you can skip this lesson. Let's start with variables and constants. When you're writing a program, you normally need to store data, and you can store data in variables and constants. For example, a computer has some memory, RAM, and this is made out of lots of spaces where you can store data. A variable stores a value that could change in the program. For example, you might have a number that changes depending on what the user inputs, and that change is represented in that variable. So the pseudocode assignment statement for a variable uses an arrow. Now in this case, we're simply saying number is assigned the value 10. Number is the identifier part, and the value or the literal, the actual data is 10. So 10 is assigned to number, or number is assigned the value 10. So number is your variable and 10 is your literal value. Now we can also have constants, and the difference between variables and constants are that constants are fixed values that don't change in the program and they remain constant for the duration of the program. For example, pi, we might want to store it as 3.14. Now before you use a constant, you need to give that value to that constant, and normally we assign values to a constant by using the constant command word. So we simply say constant in capitals, color is assigned the value yellow, and this would never change for the duration of the program. Now you could technically create a variable and assign yellow to it and not change it. But the fact is that when you put the word constant, the programmer who's going to be reading the pseudocode knows that this value should not change. So we define it by using constant, and then just like a variable, we give it an identifier and assign a value to it. Now these values can be different types of data. For example, you could have a number, which can be integer or a decimal number. Data in programs can be of different type. It could be numeric, it can be text, it can be Boolean, it can be date. You will need to tell your program what type of data you want it to store. So some programming languages, you need to declare the data type before you can store data. Now, for the purpose of our syllabus, the programming data types you need to be familiar with are string, which is always used for text, and text can be letters, numbers, or symbols. Integer, which is always a whole number, can be positive or negative. Real, which stores decimal numbers, can be one decimal place, two decimal places, or as many as you want. Boolean must be either true or false. It doesn't store anything else, just true or false. Char only stores a single character, and normally char and string need to have quote marks around it, otherwise you will lose marks in the exam. Now, how do we store different data types using pseudocode? So we start by using the declare command or declare statement. So declare color colon string. That means that the color variable is of string data type. Declare value colon integer means that the value variable has the integer data type. Once we've declared these variables, we can then assign values to it. So color can be assigned the value red, and red has to be in quote marks because it is a string. However, if we were going to use a constant, for example, the value constant, we can assign that 10 because we've declared it as an integer. So both variables and constants need declaration in pseudocode. And similarly, we can do the others. Price is real, so it's assigned the value 22.4, and flag is a Boolean, so it's assigned the value true, and true or false will also be in capitals. Now, all of this will be in the pseudocode guide, but just remember, you must declare variables, constants, and arrays in the 15 marker unless you're told otherwise. If you're using Python for the 15 markers, then you will need to declare these in a comment statement, but they must be declared unless the question asks you not to. Now, you can also convert between data types. This part is not really necessary for our syllabus. However, if you wanted to know about it, it's basically called casting, and you simply say number is assigned the value and just put the data type in front of it, int of a string 123. So that means this is going to convert the string 123 into a integer 123. So you can convert text to integers and vice versa. Most programming languages will allow you to do this. However, we don't really need to do this for the purpose of our exam, but it is a useful technique to know. So if I wanted to change a number into text, I could say text is assigned the value str for string brackets 123. That means it'll change the number into a string value and store it in the text variable. Okay, let's look at output. A program at some point will probably need to give some information to the user, and we do that using an output command. Output brackets quote marks hello world, because that's the string we want to output on the screen. Now, if you want to output more than one piece of data, you can use the concatenation symbol, which means join together. And this could be a comma, an and symbol, or a plus. All are acceptable in pseudocode. So for example, if I wanted to connect hello, which is a string, to a variable name, I could write it as output brackets hello in quote marks, that's your string, comma name, and the name would be a variable. So it will take the value which is stored in name and join it with hello and output that on screen. Next is input. So a program might need the user to enter some data, and we do this using the input command. This cannot appear on its own, otherwise data entered will just disappear into space. So we need some place to store this data. So normally you use the input command with a variable, for example, input number. Now it can also be combined with output, so you can prompt the user to enter something. For example, output brackets in quote marks enter a word. You're prompting the user to enter a word, and then you say input word. So the user's answer or their input is going to be stored in the variable word. You will of course need to declare this at the beginning, and you'll say this is going to be of type string. So all of that will need to be done for this input command to work. Now, input and output are pretty basic commands. Let's look at something a bit more complex, arithmetic operators. Now, sometimes you will need to instruct a program to perform calculations, and calculations can use parentheses or brackets to change the order, just like normal maths. For example, we can assign a calculation to the variable total by simply saying 4 plus brackets 3 times 2. So this is just like normal maths. 3 times 2 is 6, 6 plus 4 is 10, and 10 is assigned to total. Now, we don't need to just use numbers. We can also use other variable names. So you can have number 1 plus brackets number 2 times number 3 and brackets. That could also work. The common operators are plus for addition, minus for subtraction, star for multiplication, slash for division. In addition to these basic operators, we also have div, mod, and the hat symbol. The hat symbol signifies power of, whereas the div and mod work with remainders and divisors that you get through normal division. For example, if you do div bracket 10 comma 2, this gives you 5 because 10 divided by 2 gives you 5. It ignores any decimal number. So if you do div 11 divided by 2, you're still going to get 5 because it's going to ignore the decimal parts. Now mod, on the other hand, gives you the remainder after the first number is divided by the second. So mod 10 comma 2 gives you 0 because 10 divided by 2 gives you 5, remainder 0. If we decided to do mod 11 comma 2, that would give us 5, remainder 1. So the answer would be 1. Power off is just the hat symbol. So if you do 2, that little hat symbol 3, that means 2 to the power of 3, which is 2 times 2 times 2, which is 8. So do pause the video and get familiar with the basic operators. We're going to look into mod in a bit more depth because mod has one special use in programming, so it can be used to work out if a number is odd or even. For example, if you perform mod 2 to a number and it returns 0, then the number is even. If it returns 1, then it is odd. For example, mod 10 comma 2 will give you 0, therefore 10 is even. If we do mod 11 comma 2, that gives us 1, therefore 11 is odd. And we can use this to check if a number is even or odd in a program if we're required to do so. Okay, let's look at the first of our three constructs, sequence. A sequence is basically a series of statements that are executed in order they are written. So for example, on screen, you see output, enter a color, output, enter your name, input name, output name, comma, your favorite color is color. Now, this sequence will be executed by the first line, output being executed first, then the input is stored in the color variable, then we output enter your name and we store the input in name, and then we concatenate a string which says name, your favorite color is color, which is whatever the user entered. That's all there is to a sequence, a series of statements that are executed in the order that they're written in. Next construct is selection, and selection means a choice. In a selection, a condition is checked, and this determines which part of the code is run. And there are two forms of selections. One is quite common, it's if, else, and if, and the second is case. All conditions need logical operators, and these allow for comparisons to be made, and the results of the comparison could be either a true or a false. So symbols like less than, greater than, less than equal to, greater than equal to, not equal to are all part of logical operators. Do pause the video and study the examples that you see on screen. And when you're ready, continue. Okay, let's look at if statements in a bit more depth. The command if is followed by a condition that is created using those logical operators that we just looked at. There are three stages of if statements. If, which is where you check the first condition. Else if you have another condition, and you can have multiple else if statements. And finally, else, which is the last condition. So if none of the conditions above are met, this is the code that's going to be run. If you look at the example, you'll probably see that we assign the value 10 to the variable number, and then we check if number is equal to 10, then we output true. Now do notice the indentation. Once we start an if statement, the next piece of code that we write is nested inside the if statement. And the if statement has if in capitals, then in capitals, and end if in capitals, because that tells the programmer that this part in between if and end if is part of the if statement. Now we can also use the else statement to tell what happens if it doesn't meet that initial requirement. So let's look at the example here. Num is given the value 10, output enter a number, and input a guess. Now let's assume that the user types in 10. So our if statement goes if num equals guess. For example, the guess is 10 and the number is 10. If they both match, then the result of the if statement is true, then we output that's correct because you guessed it correctly. But if they type something else, like for example 5, then the first part will give you a false. So that means that part is not going to run. Therefore, you're going to run the else part of the if statement and you're going to output incorrect. Now there can only be one else statement in an if statement. So if you want to use other condition checks, then you would have to use the else if statement. Now this allows for second or more conditions if the first condition, the if statement condition, is false. An example could be num1 is given the value 10, num2 is given the value 20. If num1 is less than num2, then we output num2. Else if num2 is less than num1, then we output num1. Now in our program, it's pretty straightforward. The num2 is greater than num1, but we could change that into inputs and then get the user to type in two numbers, and then it can work out which is the biggest number between whatever the two numbers the user entered. Now, if else aren't the only selection statements out there, there is something called select case. And the select case statement allows the program to take one variable or value and then have lots of different options depending on what it is equal to. Okay, let's look at the example. We output enter score, we get the user to input the score and store it in the score variable, and then we're going to do case of score. If it's greater than equal to 80, then we output A. Then we look at the second case, greater than equal to 70, and we output a B. Then we look at the third case, compare it to that, output a C, and then a D. If it doesn't match any of the above cases, we use the otherwise statement to output a U grade. And then we end the case so the programmer knows that the case statement has ended. So what happens is that when the user enters, let's just say a mark of 75, since it's not greater than equal to 80, we won't output an A. However, it is greater than equal to 70, therefore the output will be a B grade. So do pause the video and look through the notation and get familiar with how to use the case statement. Normally we use if statement when we have one or two comparisons to do, but if you've got multiple comparisons like 6, 7, then it's better to use a case statement. Okay, let's look at Boolean operators. Just like arithmetic operators, there are three Boolean operators that you can use to join multiple conditions together. And these are and, not, and or. These are just like logic gates, which you will encounter in Unit 9. And basically means that both conditions or all conditions that are joined using the and statement have to be met for that code to run. Or means only one of those conditions have to be met for the code to run, and not means that the conditions should not be met for the code to run. Now you can look at the examples that are listed on screen to get familiar with how and or not Boolean operators work. So do pause the video and go through this. And when you're ready, continue. The final construct that we're going to look at is called iteration, and these basically mean loops. So an iteration or a loop is a programming construct where statements are run either a set number of times or a finite number of times, or while a condition is true. Now there are three types of loops as a result. The first one is count controlled, which runs a set number of times. Then is precondition, where we check the condition before we run the code. And the final one is post condition, where you run the code at least once and then check a condition. We're going to look at count controlled first. This type of loop uses a counter to run a set number of times. And the most common count control loop is the for loop. And you need to know how the for loop works. So look at the example. The for loop is using a counter x, which is set from 1 to 10. So it's going to start with 1 and it's going to keep going until 10. And for every time it runs, it's going to output the counter itself, or x. So what happens is that when the counter is 1, then it'll output 1. Then it'll go to next x, so it moves the counter to 2, outputs 2, then 3, then 4, then 5, and it'll keep going until it reaches 10. Once it reaches 10, the counter has reached its final condition, it stops. Now you can change the amount that you increase the counter by, and you can use a step condition. For example, step 1 increases the counter by 1 each time. Step -1 will decrease the counter by 1 each time, and we can increase it in step 0.5 intervals or step 10 intervals. That's entirely up to you. So how would that loop look like? It'll look like something like this. For number which is assigned the value 10 to 1, step -1. So it's going to start with 10 and it's going to then decrease the step by -1 each time, and then it's going to output the number. And then the next number says go to the next value of the counter. So for example, number will begin with 10, we output 10, then we go to the next one, it's -1, so it becomes 9, then 8, then 7, 6, 5, 4, 3, 2, 1. So do get familiar with count control loops. The next type of loop we're going to look at is a precondition loop, where the condition is checked at the start of the loop, and this is normally a while loop. So how does a while loop work? Let's look at an example. So we're going to assign the variable input value the value of yes. So while input value equals yes, do the following. Now this creates an infinite loop. So input value is yes. So this loop, while loop, is going to run forever until the user inputs a value which says no or something else. So as long as the user keeps typing in yes, the loop will carry on asking, do you want to continue? Yes. Do you want to continue? Yes. Do you want to continue? No. And then it'll exit the loop and stop. A post-condition loop, on the other hand, runs the code inside the loop at least once and then checks the condition at the end. This means the code will always run once, and that can be quite useful as well. So for example, instead of us assigning the input value to yes, we could have used a post-condition loop and get the user to input the value and then check the condition. So how would that look like? So let's look at the example. Repeat output, do you want to stop, input whatever the user's answer is, and keep doing it until the answer is equal to yes. So what happens is the code runs once. Do you want to stop? User is prompted for an answer. The user will say yes, and the loop ends. Now, in an exam, sometimes you'll be asked to convert a for loop to a while loop or vice versa. So if you look at the loop on screen, for x is assigned the value 1 to 10, then we output X, and then we move on to the next X. Now, in this case, how do we convert this to a while loop? So the strategy is step one, to declare the variable that you're going to use as a counter, because a while loop does not automatically count. We then take the last value and put it in the while loop as a condition. So in this case, the last value is 10 in the for loop. So we're going to make sure that's there. And then we're going to increment the counter in the loop. So it will look something like this. X is assigned the value 1 because that's our starting value, while X is less than 11, or while X is not equal to 10, keep doing the following. There are multiple conditions you could use here. That's your step 2. And then we simply output X. However, since a while loop doesn't increment itself, we will need to say X is assigned the value X plus 1. So we manually ask the program to increment the step, and we finally write end while to end our loop. If we were to use a repeat until loop, we'd probably do something similar. We'll assign the value of X to 1. We'll keep repeating output X, and then we'll say X is assigned the value X plus 1 until X equals 10. So all the loops can be converted to each other. However, your job in the exam would be to pick the most efficient way to do an iteration. So if they give you a fixed number of times, then better to use a count control loop like a for loop. If they ask you to check a condition first, then a precondition loop should be used. And if they ask you to run the code at least once, then a post condition loop should be used. That's all for this lesson. Let's see if you can handle the following questions. You should be able to describe the difference between precondition and post-condition loops. You should be able to answer questions like the following. A program needs a loop that will run 50 times. Which type of loop would be the most appropriate? You should also be able to write a program to output numbers between 100 to 200. They could give you any type of scenario like that. You should be able to write programs that ask the user to enter a number continually until they enter the number 10 using perhaps a post-condition loop. You should also be able to convert a count control loop to a precondition loop or a post-condition loop, and vice versa. So do pause the video and go through these questions. And if you do struggle with something, get back to me using the comments. That's all for this lesson, and I'll see you in the next one.